All right. I want to know if somebody has a way to describe from these graphs how they're getting this slope of 2 and the slope of -1/5.
So that one, we're over 1 up 2, over 1 up 2.
Oh. And what about this one?
And you're going so if we're starting from the left, we're going down 1/5, over 1, down 1/5, over 2, or just over 1. Down 1/5, over 1, down.
Or could we say down 1 over 1, 2, 3, 4, 5?
So every one.
Could I go up 2 over 1, up 2 over 1?
Wait,
Oh.
shouldn't that be 1, 4, like 2, 4 or something?
Okay, well, we could say that we go up 1, 2, 3, 4 over 2, but 4 over 2 reduces to what?
2.
2.
So no matter. So on the 1 over 2.
Okay, so we have a fraction. In this case, we went up 4 and over 2. So 4 divided by 2 is what got us the 2.
Wait, so
Over here, you saying we went down 1 over 5.
So x would be the denominator, so then you divide it.
That's what I understand.
We don't have to understand right now, okay? What is really irritating me is that there's side conversations happening right now. Okay, so what Henry pointed out to us, that if we count up and over or down and over, we get our slope. Okay, this is what we call rise over run. We can count the rise and then we can count the run, and there's our slope. We'll talk more about it. Okay, now, did anybody recognize anything in these two? Kyron.
Every one that is subtracted 2.
Okay, so we're like going up by 1 here, right? But we're subtracting 2 here.
Yeah, I think I get it.
Okay, so we have a pattern of -2 and +1. Okay, what about this pattern over here?
The x, you add 4, and then for the y, you add 1.
So -2 over 1 gives us -2. 1 over 4 gives us 1/4. Okay, you still don't have to completely understand it right now. We're going to talk about it a lot, but I do need you to have your student journals open to this page right here. Reese, I'll take that. You really want to go right now when we're about to talk about one of the most important things ever?
Absolutely.
I mean, you can, but I'm just warning you, this conversation we're about to have is pretty important.
What page are we
Okay.
on?
We're on page 81 at the end. Okay. We're on page 81. Okay. So our slope is our constant rate of change that we keep talking about when we talk about, is it linear, is it not linear? Okay. The constant rate of change, that concept, that is what we call slope. Okay. When we look at a graph, we calculate slope by looking at the rise over the run. If I have 1 point and another point, if I go up or down and then over, if we count those, we're going to make those numbers into a fraction. Okay. What's kind of strange about slope is that we use the letter M to indicate M for slope. Don't ask me why. Okay. However, if we have 2 points, let's say the first one is x1, y1, and the second one is x2, y2, we are going to calculate rise over run by, rise is up and down, do you agree? So we're going to subtract our y coordinates from each other. Run, that would be horizontal. We're gonna subtract our x coordinates from each other.
You do the large number
Could you
first.
explain that one more time?
Oh my.
You do the large number first.
I do.
We just need to pick a coordinate and make sure it comes first at both times. These are twos. Okay, so Kyron, I have 2 coordinates. Here's the first coordinate, here's the second coordinate. In the numerator to calculate the rise, I'm gonna take y minus y. That's what that says right here.
What's the two?
That's the same.
That's like the second coordinate y. And the 1 is the first coordinate y.
I asked that question. As long as you have the same.
Okay, so if this y is what I have right here, then the x that goes with it has to be directly underneath of it. Okay. Yes.
And again, I don't know if you answered that question or not, if I didn't hear it, but, does the 2, the second number, have to be the largest number or just any number?
Not just any number. Okay,
Which the coordinates?
so you're gonna pick which coordinate you want the y to be here, and from that same coordinate, that x better be here. Okay, whatever the other coordinate is, that y and this x, they should be from the same coordinate. Okay, now it is important. Okay, so here's like this picture right here for you. All right, it's important to understand when slope is positive versus when it's negative. So I want you to go to the next page. Do you have to turn? Yes, you have to turn. Okay. So here is positive slope versus negative slope. Okay. So when you're thinking of slope and trying to remember when we have positive versus negative, I want you to think of somebody skiing. If I was skiing, yeah, you'd have to work pretty hard, right?
So that'd be negative.
Maybe a negative.
So positive would be negative.
No. Puff, puff, positive. I would have to work really hard if I wanted to get up the hill because it has positive slope. Okay, but if we have negative slope, it would be really nice because I would just slide down.
Or you could put like,
Okay. Okay, or from left to right, does it rise or does it fall? If it rises, you have positive slope. If it falls, you have negative slope. Rises, falls. Okay. Now, if I'm skiing, this would be 0 fun.
Well, unless you had poles.
Okay. So this is a slope of 0. Hey, Brooks, what would happen if you tried to ski down a vertical line?
That would be pretty fun. About a second.
fall.
What would happen to you?
You would get,
You would be undefined.
I don't know what the unidentified is.
Undefined means.
But it's snow. But it's snow.
You would die.
But it's snow.
You would be undefined. You would be LR.
You'd be unalive.
Okay?
Snow catches you.
Okay, you know what? You remember it however you want to remember it. But this is zero slope and this is undefined
But
slope,
this doesn't
okay?
make any sense.
Why does it make any,
But
why?
then it doesn't make sense, because then undefined doesn't mean anything.
This
Why do we do that? Why do we do examples? I think just stop.
Okay. Go to the next page. You see this number one right here?
I think I'm seeing it.
Okay. Brooks, what is our slope?
Undefined,
Undefined. How do you know that?
because if you were to ski down it, you would die.
Okay, it's a vertical line. We have undefined slope. Now, what I would like to show you is how we would calculate this using our slope formula. Okay, so I'm gonna call this y1, y2, y1, x1, y1. I'm gonna call this x2, y2. So what I would do if I was using just the coordinates and not the graph to calculate the slope, I would take -4 minus 4 because I'm taking y2 minus y1. Then I would take x2 minus x1. So I would have 3 minus 3.
Zero over zero.
So how would be -8 over 0? People, hey. Which is why I have -4 minus 4. So we have y2 minus y1 over x2 minus x1. So I took, here is my y2 in blue, here is my y1 in green. You see what I'm saying there? Okay, now can we divide by 0?
Actually, yes, you can.
Actually, no, you can't.
Well, you look at me funny.
It'll say here.
No, this is, give me 0. If you divide by 0.
No, you cannot
Zero,
divide.
error.
Now, if this were 0 over -8, that would be 0, but we cannot have 0 in the denominator. No good. Let's look at number 2.
You have to, when we were showing our work, I used to get this whole thing.
Yeah, that's fine.
Okay. Now, there are, so if we have a graph, we can simply count on the graph. So if we do rise over run, if I start on this left point, I'm gonna rise. How many am I rising?
2.
What? Wait, 4.
I think that's 8.
Yeah.
Oh,
Negative 4 to positive 4.
And then I'm gonna run. How far do I run? 4. So if we put rise over run, 8 over 4, we would get, and is it a positive or a -2? Positive, because my line is rising from left to right.
So the answer to the question would be 2.
Correct.
Alright.
Okay.
I thought it would be positive.
No, Kyron, that's what.
It is positive, which is why it's a +2. Okay. Kyron, what kind of slope do we have in number 3? So we better have a negative number when we calculate slope. Okay. So if I'm going to rise, well, I have to go down, right? So if I rise, how many am I going down? 1, 2, 3, 4, 5. How many am I running? So our slope would be a negative because it's falling 5 over 5. So we get -1. Okay.
Another way. So remember, even with this, when the rise be a negative rise, you just write
So you could think of that too. You could say, hey, I'm going down, so this is a negative
Yeah.
5, but I'm running to the right, so that's a positive 5. Okay? That would be fine. Okay. Now, we are going to do some practice. Yes. Okay, so do you want to practice so we can see how we get -1 from the equation? Okay, so if you have a graph, do the graph. But let's practice using our slope equation because that's what you're going to do here in a moment. Okay, so if we are going to find slope with the slope equation, then I'm going to say, okay, here is y2 minus here is y1. You see how I did that? Y minus y. Now I'm going to look at x and notice how I'm grabbing from the same coordinate 3 minus this x -2. Yeah, so we have -5/5, which, whoa, who would have thought? -1.
Maybe some people don't. Yeah.